So my real goal today was to have a nice little quiz, but I got so excited about trying out Pear Deck, which has been quite the challenge for me all day, but I think may be good, we hope. Um, anyway, I got so excited about it that really the Pear Deck review is taking pretty much all of class. Therefore, I have changed the quiz plan to Monday. You'll see if you go to Google Classroom just now before our class. Excuse me. Just before we started class, I changed the date on the quiz to the date of Monday, but I am leaving the quiz open. Like, you could get into it anytime you want over the weekend, but you're not required to. That's why I changed the date to Monday. If when we're done reviewing here, you're like, dang, this is all fresh on my mind, so taking a quiz now while it's all fresh and in front of my face, I want to do it sooner rather than later, that's fine. You can do that, but nobody's obligated to work on it until Monday, okay? So everybody cool with that while we're talking about bears and sharks? Dang. All right. Thanks for making a fun Friday. So I am going to get out of that, and we're going to go right over here. And I have already invited all of you to this Pear Deck. So I'm about to stuff this link in, but even if you just typed in joinpd.com, I believe that you would see this activity appear on that page. So you could go to joinpd.com, that's for joinpeardeck.com, and there would be a little place that even if you didn't follow my link, you would see a place when you go to joinpd.com that it's telling you, it's giving you a link to this activity. All right, come on. It's not this complicated, I know it. What's going on? Don't be so nice. It's just not good for us. All right, I'm following the link because, I want to be cool like all you guys. I've been suggesting to people that they might want to make their Zoom session one half of their screen and the Pear Deck the other half of the screen. You get a little opportunity you can skip it, but you can share how you're doing today. I've got another one inside the Pear Deck as well. It's kind of like that. Why must we make it a battle? It's not a battle. We're working together somehow. The battle is against ourselves. When we want to be mean, we must find a way to be nice. Sometimes that's very
That is all Jalea. She is the one that's being
toxic. All right,
toxic.
I see 12 of us are in. We got 13 peoples. So I think one person is not in yet. Actually, no, there's 2 people not in because I'm one of those 12 right now. So there's only 11 students in. All right, I'm gonna take that away. The link is in the chat though, if you can find it after all the other things people have said since I put the link in. Thanks, Mr. Blake, appreciate that. All right, so much like Desmos, Pear Deck actually allows us to, trying to see if I can adjust this light so my face isn't too dark but not shining in my eyes. Pear Deck allows me to either put us all in the same spot. You know, I've done that with Desmos sometimes, or allow you guys to work at whatever pace you want. We're going to spend most of this class period all in the same spot in this Pear Deck, but at the end of class, I will turn it over to student paced, which means you'll be able to go wherever you want and you'll be able to get back into it until I close it at some point, probably toward the end of the weekend is my guess. So here we go. Discrete versus continuous. The next slide is a stress check. Life in general, you see that purple bar, you can drag it where you feel that it fits in. I'm in a good space and can focus. There's like next to no stress going on for me, or my brain's a little fried, or I'm so stressed it's crazy. Whatever the answer for you might be, here I can show you where your classmates are landing. I'm not sure if I said it to you guys, but a nice thing about Pear Deck is all your answers are totally anonymous. I can see who's who, but in terms of anybody else in the class, they can see that lots of people are responding like so we can share our responses, but there's not any names attached to it. So, you know, we don't know if it's Mr. Reed that put himself up past 10 or not, but I want to be aware, guys, when I know lots of us are super stressed or something, that I want to be taking that into consideration as we try and make choices and do stuff. I'm about to move on. I don't want to spend too much time on this right now, but it is important to me if you guys are feeling extra stressed. I don't want to do lots of things to add lots of stress to you. All right, here we go to the next one. We're going to start out just looking at what are the characteristics of discrete functions, what are the characteristics of continuous functions, what you've been working on in that Desmos activity since way back last Friday, but we only had last Friday, then Monday, and then yesterday, Thursday, to work on it so far. Here's discrete function. A discrete function has a domain that will be a list of numbers. So you see my example there. This curly Q bracket, remember it's our set notation. It indicates that I'm about to write, identify the elements of a set. So we're going to be wanting to use that when we get toward the end of this, because we're going to talk range, domain and range of functions. And when we're doing discrete functions, we'll be using the curly Q and listing out the individual members of the domain. If it's a discrete function, it's going to be a situation where we can count and there's not going to be like pieces and parts involved. So we might be counting how many people are at a party or how many Snickers bar people eat each week, Snicker bars. And while, yeah, you could eat half a bar, typically we're going to be talking about a whole bar or no bar or 12 bars, or so something that's countable and typically not something that you're looking at small pieces of. That's what makes it discrete. When we're looking at the graph, it's going to be, I've made my new little phrase today, it's disconnected dots that would be on a discrete graph. You hear all those D's? Disconnected dots, discrete. So the reason this graph would be representing a discrete function is the fact that it's all disconnected dots, not just the fact that there are dots on it. Because if all these were connected, then it would be continuing. So it would be what we call continuous function. A situation I gave for a discrete function is the number of people attending each performance of an opera. Just one example. There's tons and tons and tons and tons of examples out there. Anybody have a question about a discrete function before we look at continuous functions?
Wait, so can you put it in like a simpler form? So
I'm thinking we should shut the chat discussion down for the moment so we can all be absorbing as much information, because what's about to happen is we're going to move from these two explanations to you guys seeing if you can identify stuff based on what we're talking about right now. So continuous function. The domain cannot be listed as individual values. Because it's continuous, there's going to be many, 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 many numbers involved. Even if we were talking about a continuous function that only went from the number 0 to the number +1, there's still infinitely many numbers in there because you got 0.00001, you got 0.00002, and if I'm talking in thousandths, then just going from 0.00001 to 0.0 or to 1, that's 1,000 numbers already, but we could go to 10 thousandths and so on and so forth. So there's no limit to how many numbers we could actually put just between 0 and 1. So that's what we mean by a continuous function. And because of that, we can't just list out the domain in set notation. Instead, we have to switch to an inequality like this. This one would be saying that the domain is every number between -2 and 12. So -2 is less than the elements in our domain, but all of the elements in our domain are less than 12 is what this inequality is saying. But if we're talking about a continuous function, we're going to need something like that in order to be able to identify the domain. It's not going to be countable. Unlike a discrete function, now I'm talking about maybe measurements, like the distance between 2 points. There's an unlimited possibility there because you can make your measurement pretty exact. It could be a measurement of how much liquid goes in something. It could be a measurement of how heavy something is. All kinds of measurements would be talking continuous function. Time would be a continuous situation. So we already pointed out that we'll be using inequalities for the domain range of continuous functions, and that the graph is going to be a line or a curve like you see over here. Now I put this graph in there because I wanted people to see that this is continuous, because once the graph gets started, there is never a point that it stops. There's never a gap in this graph, okay? So as long as there's no gap, it's going to be called continuous. It does not matter that we happen to have dots. The big deal is they're not disconnected dots. They are all connected to this graph, okay? And then a situation, just one of many for a continuous function, how many gallons of gas are put into the gas tank each time a car is refueled? Well, the amount of gas that goes in a car, if you look at the fuel pump, that's always at least in tenths of a gallon and often clear into 1/100ths of a gallon. So that's going to be a continuous situation. All right, any questions? I'm going to put it out one more time. Discrete graphs, disconnected dots. All right, continuous graphs, they are going to be a solid curve or solid line. And here comes our opportunity to identify them. You're going to be able to choose an answer here, but if you've got your window small enough, you may need to click that little green button in the lower right corner of the window. For me, the way I've got my Chromebook set up right now, I've got a little green button that says answer question. I can click on it, and then if I click on it again, it takes me back to the question so I can see it. So I can go back and forth between the question and my answer. And I see several people have already answered. We got 6 answers going right now. Remember, I've been saying discrete is disconnected dots. There are kind of some dots, or at least an open circle and a dot going on here. Are they disconnected? Because if they are not disconnected, then it is not discrete. All right, so I'll show you our responses at the moment. We got 5 people saying continuous and 1 person saying discrete. I very much agree with the continuous. So if you put discrete, you can go back to where you do your answers and change that answer to saying continuous. Okay. All right, moving on to the next one. Well, we got 9 of us, and there's supposed to be a good 14 of us. I'm not sure where the other 5 are. May not have said it. It says it in our Google Classroom. This is a participation grade, guys, so don't miss out and end up with a crummy participation grade today. All right, continuous or discrete here. Disconnected dots are discrete, or would be a discrete function. Disconnected dots are a discrete function. Here's where we're at. 7 of us are saying discrete. 3 of us are saying continuous. And we got 8 people saying discrete. I agree with the 8. So if you happen to say continuous here, it's definitely discrete. When I start here, I can't just walk right along the path. If I tried to just walk right along the path, I'd fall down into oblivion. I'd have to find a way to jump from the first dot to the next dot, okay, because it is discrete. All right, moving right along. Continuous or discrete? Let's see if we can pop our answers in pretty quick and keep rolling. Disconnected dots are the only kind of graph that would represent a discrete graph.
Wait, did you just say that's a discrete graph?
Overall, we're looking pretty good. 7 of us have said continuous. I agree with those 7, now 8. So one of us might want to change our answer from discrete back to continuous. That is definitely continuous. When I get started, I can walk right along this path. I'm never going to fall through. Just keeps going nice and smooth, no problem. So that is a continuous graph. Discrete or continuous? Got some people hopping in there darn fast. Only if it's disconnected dots can it be discrete. This graph does have a dot on it, but it's not disconnected all by itself out in the middle of nowhere. It's on a solid line graph. So I like the answers. Everybody so far that's given me an answer is saying continuous. I definitely agree with that. And we'll just keep going. Continuous or discrete? All right, I do believe that these red dots are disconnected red dots. There's nothing connecting me from this top red dot to the next one down, just completely separate from each other. That's when I know it's definitely going to be a discrete function. So if you chose continuous, switch your answer to discrete. All right. So here's what I'm really appreciating about you guys right now, among many things, but you guys are just a great class to work with. Here's one last one. I've had too many classes today where I share the correct answer and ask people to change their answers, and they just left their wrong answer in place. That doesn't help a whole lot in terms of your own making sure that you are identifying things correctly. Everybody that's given an answer to this one so far has been correct. 7 people have got the answer of discrete. Do we have a few more people that are going to get their answer up there? There's 8 of us all saying discrete. Very good. I think we're beginning to get hopefully beginning to get a better handle on what in the world does the graph of a discrete function look like versus what does the graph of a continuous function look like. Good job. So let's take a look at domain and range now. I'm just going to try and make sure as best I can that we are comprehending. Hopefully we know that domain deals with the x values, the inputs, but those, when I'm looking at the coordinate plane, those are the values that the graph represents along the x-axis. When it's a discrete graph like this, then I know that I'm going to be looking at each part of the graph and figure out what x value does it have. Remember, we're going to use the curly Q bracket, which is up there next to the letter P. You'll have to do shift and the key right next to the letter P to create the open curly Q. All right, and then the lowest value of x that is going to be in the domain here was a 2. Then we've got this 3. The purple dot is an x value of 5. The black one is an x value of 7. And the red one has a value of 9. So my domain would consist of the numbers 2, 3, 5, 7, and 9. Be sure to separate them with a comma and then close it with our curly bracket. Okay, so I've got a few people that have got answers that are pretty correct, except they haven't put their curly cube bracket. I've got others. Sorry, let me get rid of that drawing for a minute. I've got others. We can do this, that have them formatted beautifully. Curly cube bracket, 2, 3, 5, 7, 9, curly cube bracket. Okay. I know that seems like maybe we're making a big deal out of nothing, but the curly cube bracket is called set notation, and it is the way that in the world of math you denote here is a set of something, and then you put all the numbers of the set inside. So that's why I want to make a big deal about it, because it does matter. It's kind of like a capital letter on the first word of your sentence. All right. I think we're doing pretty well. Looks like those people who are participating at the moment have it. Let me move on to the next one. So that was domain. We got the same function, but we just changed to the question being, what is the range? Still going to do that same kind of notation. Just remember, now we're looking at the y values. So if I want the y values, then I'm going to have to look at each point on the graph and look over to the y-axis. Here's all the y values that are going to be involved. So a 1, 3, 4, 5, and 6, that would be the range of this function. Talking about the same points, just looking at how far up or down they are. All right, we got 6 responses going here, all of which are looking very good. A couple of them I see kind of, it's good to list them in numerical order. I'm not going to count it right or wrong based on that, but you know, if it's something that really mattered, like a standardized test, I would definitely make sure you list things in numerical order, just because that's kind of a mathematical standard way of doing this. All right. We just got 2 more slides that are about domain and range, and they're going to be continuous ones where we're dealing with identifying the domain and the range using inequality symbols. And by the time we're done with those, we're going to be right at the end of class. I'm just waiting a moment because I see a person or two that, well, maybe that person's not typing anymore, so we'll just keep rolling. Okay, the correct answer, here I'll just show some responses because they're pretty correct. I think this first one up here is probably the most ideal. Trying to get rid of the drawings for us. The 1, 3, 4, 5, 6, they're in numerical order there. They're in the curly brackets. We got one here that has all the correct numbers listed. They're just not in numerical order, not counting it wrong at all, but just good to keep things in numerical order when we can. So well done there. Moving right along. The domain of this graph. So it's a very similar idea. We got to figure out what x values are covered by this graph. And so we see that this graph has an open circle here on -3. Okay, and then once I start moving right, I've got graph below me all through here, right up until I get to 1 where it ends. If I went past that, there wouldn't be any more graphs. So I'm just drawing a line here to show these are all the X values that are covered. So I'm trying to show my domain just based on the fact that it starts down here. This was at a -3, goes all the way until I get to +1. And so I do not like, I think I didn't even point out to you guys, I don't like the fact that right now in Pear Deck, this is pretty much the only way, this right here is the only way I know of, and maybe I'll figure something else out, to write this symbol. This is the normal mathematical notation. Less than or equal to would be a less than sign with a single bar underneath. There's probably a way that we can make that happen, but right now, I don't know what it is. So we'll just do this different way. That means I'm going to start with the smallest X value I have, which in this case is a -3. It's not included. That open circle means I'm going to use just a less than sign because -3 is not actually on the graph, just a boundary point. And then I need my X because I'm talking about domain. That's my X values. And then I need to include the 1. So it would be a less than or equal to sign, which I'll write it this way, as painful as that is for me. So I have -3 is less than X is less than or equal to 1. That's what I'm looking for as your answer. I see one person. I want to call out their name, but I won't rudely do that. I see 2 people have that notation just ever so perfect. One person is telling me -3 is less than 1, which is a true statement. We just need an X in between those. Looking good, guys. One person put our curly Q brackets around this, but while this is identifying a specific spread of numbers, it's not really a set. We normally use set notation when we're listing out individual members of the set. All right. Looking good, ladies and gents. And then, just making sure nobody else is trying to pop an answer in here. Here's all your gorgeous responses. Gorgeous. Come on, can we find something wrong with them, you know, so we can just be really picky? Unfortunately, you guys are so with it that I can't find anything to try and tell you to correct. Well done. So we're moving on to this one last slide that we're going to try and give an answer to. This time it's the range though. So as I think about the range, I'm talking about my Y values. And there's an open circle over here. However, I believe that right here, this actually crosses the 0. So I'm going to make it a closed circle at 0. That's as high as it goes. There's not anything for the graph up at this height, but it does go down from here. So if I am following it down, I see that right here at -4, that's the lowest it goes. So, but it does have a closed circle dot on -4 over there. So those are the values. The lowest one is -4, the highest one is 0. Both of them are going to use less than or equal to because those numbers are included in the range. So -4 is less than, I want to write it the right way, but I'm going to write it the way I know you have to type it. So -4 is less than or equal to, we are dealing with Y values now, so make sure you put a Y in there. And then less than or equal to, and the highest value we said was a 0. Okay, so that's what our answers would look like for this range question. So we did one function that was discrete, used our set notation. Now we've done one function that's continuous and used inequality notation. Thank you guys for participating. It definitely helps me know that you're with me, and I won't always use it quite like I did today. There'll probably be times that I actually use it more to see what you know without me telling you answers. But today I just felt like we hadn't really discussed this in depth together as a class, and so I wanted to make sure we did. Do we have any questions at the moment, guys?
There's a question in the chat, Mr. Reed.
Julia said, are we supposed to keep it in numerical order or not? It's great if you can. With the inequality symbols, you definitely have to, because this is a less than symbol. So the smallest number has to be over here on the left, and then the biggest number would have to be on the right. That's really important in the inequality notation. The set notation is not nearly as important. As long as you list all the numbers, it's okay. The mathematical standard is usually to put things in numerical order, but that's not going to make if you're doing the set notation for a discrete function, that's not going to make your answer wrong if you don't put it in numerical order. Great question. Thank you for asking it. The last two slides are this one, which is an opportunity for you to tell me how you're feeling about the stuff we talked about. And the very last one, you can be real specific and type out, hey, Mr. Reed, you confused the living daylights out of me on this topic. What I'm doing right now is making this student paste so you can go anywhere you want, just like you normally can in Desmos. You can go to any slide, you can do whatever you want with this Pear Deck session right now. There is a link to it in our Google Classroom assignments. If you needed to get back to it, you also should be able to get back to it just by making sure you're logged into your school Gmail account or school Google account, and then going to joinpd.com. You'll see it listed in your recent activities if you do it that way. All right. Thank you guys all for hanging in there. I'll stop